Hello everyone, welcome back to Deeksha Karnataka YouTube channel. Today I am going to solve top 30 questions from the chapter moving charges and magnetism. Okay, so without any delay, let's start with top 30 questions of moving charges and magnetism. And obviously if you want to practice more questions, obviously you can join our Abhyas test series. Also, if you have not yet subscribed to our channel, don't forget to subscribe to our channel. And this chapter is very important in terms of KCET preparation. Okay, 4 questions you can expect from this chapter. Let's see the questions. The torque acting on a magnetic dipole placed in an uniform magnetic field is 0 when the angle between the dipole and the magnetic field is. So what is the formula? Torque is basically mb sine theta. Okay, so if this is 0 and m and b both of them are not 0, dipole moment, magnetic dipole means obviously dipole moment is not 0 and it is placed in a magnetic field, so definitely only way it can be 0 is sine theta is 0, that is theta equals to 0. So the angle is theta equals to 0. So if the angle between them is 0, that is they are parallel to each other, then the torque acting on it will be 0. Now next question. A very long straight wire carries a current I. At the instant when the charge plus Q is at a point P, has a velocity V as shown, the force on the charge is. So you have to, there is an infinitely long current carrying wire which is carrying a current I, right? You can see that, there is a charge Q placed at the point P. When the charge is at this point, what is the direction of force acting on this charge, right? Very interesting question. So first what we have to do, we have to find the direction of magnetic field due to this current carrying wire. Okay, so this current carrying wire is carrying current in the up direction, so we will put our thumb in the direction of current, and if we curl your fingers, then the direction of our fingers will point towards the direction of magnetic field. So here the magnetic field due to this current carrying wire will be into the page of the paper, right? If you have any doubt, you can ask in the comment below. So magnetic field will be into the page of the paper. So direction of magnetic field is in this direction, magnet and velocity is in this direction. So what is the direction of force? Lorentz force states that the force is basically Q into V cross B, right? So now we have to do the cross product to find the direction of this force. Okay, so direction of the force will be, V is in this direction. First we will point towards V because V cross B. So first we have to point our fingers in the direction of V, and then we will curl our fingers towards the second vector, that is B. B is into the paper, so we will curl our fingers towards the paper, and we see that our thumb will point towards the direction of the magnetic force on the charge, right? Now if that current was in the opposite direction, then how could we have done that? It will be like this, so it will be in the opposite direction, right? Clear? So charge is positive, so the force on the charge will be in the direction, upward direction. If it was a negative charge, after doing that you have to take a reverse of that. So very careful, this kind of questions are super important. Charge, it depends, the force or direction of the force depends on the polarity of the charge. Obviously Q, if Q is positive only, then only we can apply this logic. If Q is negative, after applying the logic you have to take the reverse direction. Okay, everything will be same after you find the direction. So for example, if the charge was negative, after finding the direction upwards, you will be say charge is negative, so the force should be in the opposite direction. Now in this case, what is the direction upward? Upward from the direction from the axis given, it is basically along OY. Okay, so along OY is the direction of force. So correct direction, correct answer is along OY, right? Now next question. A proton and an alpha particle moving with the same velocity enter a uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular path is. So how to solve that? So first of all, what is the force acting on it? Force acting on it is Q VB. Okay, and if it is a moving in a circular path, obviously they are perpendicular to each other, and that from here we can say that mv square by r. Okay, so this is the mv square by r is the centripetal force. Okay, so we have to find the radii I, r. Okay, their velocities are same, so v will be constant anyway. So let's see what is the relationship. So r equals to m by qb. So r equals to m by qb. So it depends on mass, it depends on charge as well. Okay, so first so basically r proton divided by r alpha particle has double charge, okay, plus 2 charge, right? Proton has only 1 plus charge. So what is the value? It will be m mass of proton divided by charge of proton, and the entire thing is divided by mass of alpha particle divided by charge of alpha particle. Okay, so it will be QHE into mass of proton divided by Q of proton into mass of helium. Okay, so what is the charge of a helium? Charge of alpha particle, charge of alpha particle is 2e, as I said, plus 2e. Mass of proton is 1. I am assuming mass of proton is mass of proton, keep it mp, okay, don't worry. And what is the charge of proton? Charge of proton is only e, and mass of helium is equals to 4 mass of proton. It has 2 protons, 2 neutrons, right? So there will be 4 over here. So e cancels, mp cancels, so we get 1 upon 2, so it will be 1 by 2. So the ratio is 1:2. So 1:2, option C is correct answer. Now let's move on. A moving coil galvanometer is converted into an ammeter of range 0 to 5 milliampere. Okay, so here we are converting a galvanometer into a ammeter of range 0 to 5. The galvanometer resistance is 90 ohm. So galvanometer resistance is 90 ohm. Okay, and the shunt resistance has a value of 10 ohm. So shunt resistance has a value of 10 ohm. Okay, if there are 50 divisions in the galvanometer, so number of division is 50. Okay, galvanometer turned ammeter on the either side of 0, its current sensitivity is, okay, so current sensitivity is what is the maximum current it can measure divided by the number of divisions. Okay, so maximum current it can measure divided by its I think there is a mistake in this question. These will be minus. Okay, these values will be minus. So what is the sensitivity? Current sensitivity. Current sensitivity is basically current, maximum current it can measure. What is the maximum current it can measure? It can measure maximum 5 milliampere current. What is the number of division for that range? So number of division is 50 milliampere. So number of division, it does not matter what is the resistances are given, it is not required here. So 5 milliampere means 5 into 10 to the power of minus 3 divided by 50 divisions. So 50, so it will be 10, 1, so 10 to the power of minus 4 ampere per division. Okay, this is the current sensitivity. So 10 to the power of minus 4 division. Here also this is wrong. One of them will be 10 to the power of minus 4. Both our options are given same. So these are the some typing error. So this will be 4. So 1 into 10 to the power of minus 4 ampere per division. So the unit basically gives you the idea how to solve it. So it is basically just you have to what is the maximum current it can measure? Maximum current divided by the number of range, amount of range will give you the division. Now it is said that both side of the galvanometer. So that means here we have 0, here we have 50 division, here we have 50 division. So when the no current is flowing, okay, if the no current is flowing, the galvanometer will show like this. So if positive 50 ampere, it will go in this direction. If negative 50 ampere, it will go in the other direction. Okay, so don't consider 50 plus 50 100 over here. It will be only 50, the maximum current in any one of the direction. If it is a full scale reflection, like if the needle starts over here, and if it is goes like this, then you have to consider the total number of division. Other than that, this is a very simple question. Now if you want to solve more such questions along with us, all the teachers, and if you want to practice more questions, then definitely you should consider buying Abhyas KCET test series, which is available only for 1498, and it is very good practice platform for your KCET preparation. Right, you will get questions, already questions are going live. So if you have not yet purchased it, go purchase it now. The link of this is given in the description. Okay, don't wait too long before it is too late. Okay, almost we have done 4 part tests of each subject. In fact, in maths we have done 6 part test. Part test is basically where we are covering up a specific syllabus, including 60 questions, and now we have started our full length test, where a full paper just like KCET exam will be given to you. You have to solve it within 60 minutes time. Okay, and it will be a computer based test. So you will have the screen, you have to choose the correct answer. Once you have chose the correct answer, you have to click next, then the next question will come like that. I have already done a demo on that, right? So if you have not yet purchased, go and purchase it now. Okay, also if you have not yet subscribed to our channel, don't forget to subscribe to our channel as well. Now this is a very interesting question. Okay, this similar question, same question actually came in 2023, but that question had some error, but we have corrected that error. I will discuss it. First, let us understand what is the question. A positively charged particle of mass m is passed through a velocity selector. Okay, velocity selector means we will see the condition for velocity selector as well. It moves horizontally rightward without deviation. So here we have a charged particle. It is moving in the rightward direction. Okay, and it is not deviating from its position. Okay, that means the force acting on this charge due to electric field and magnetic field, they are equal, they are cancelling each other. That is why this charge can pass directly. That is the condition for velocity selector. On any other velocities, any other directional velocities, they will be they will generally coming out of the magnetic field. Okay, because they try to move in a circular motion, and they will come out. Only the particular velocity, particular direction will be there. Okay, without any deviation, the line y equals to 2 mv by qb. So the line of this is 2 mv by qb. So this is the distance. Line means this is the line equation. Line equation means obviously this is the distance from the origin. With the speed v, the electric field is vertically downward. The electric field here is vertically downward. Okay, and the electric field is vertically downward, and the magnetic field is into the plane of the paper. So as you can see, magnetic field is into the plane of the paper, so it is in this direction. Now the electric field is switched off at t equals to 0. So as soon as this charge came over here at t equals to 0, okay, the electric field is switched off. Okay, the angular momentum of the charged particle about origin O at t equals to pi m by qb. So time, after time t is equal to pi m by qb. So these are the facts that you have to consider, and then you have to find the angular momentum. Okay, so this is basically a mixed concept question. Obviously angular momentum you have studied in first few. Let's see how to solve this question. First we have to find what is happening when the electric field and magnetic field both are present. So when electric field and magnetic field both are present, electric force and magnetic force, they are cancelling each other. That means what is the magnetic force, direction of magnetic force here? So the particle is moving in this direction. I already gave you one problem where you have solved it. So particle is moving in this direction and the magnetic field is into the page of the paper. So the direction of magnetic field, direction of the magnetic force will be in the upward direction. So magnetic force upward direction. What is the direction of electric force? Electric force positive charge, that means it will be in the direction of electric field. So electric force will be downward and magnetic force will be upward direction. So this will be electric force and magnetic force will be upward direction, and both are equal. That is why it is going undeflected or undeviated. Passes undeviated means or without deviation means these two forces are equal. So QVB must be equals to Q into E. Okay, QVB is the Lorentz force and Q into E is the electrostatic force. They are basically equal. So from here you can say that V equals to E by B. At the beginning, this is at the beginning, V is equal to E by B. That is required to find one of the forms later on. Right? So this is the first stage. This is the condition for velocity selector. As I said, there is a condition for velocity selector. So if the velocity is equals to E by B, then only that velocity will be allowed to pass through that electric and magnetic field. Any other velocities will not be allowed. So this is the condition for velocity selector. Next is we have to find the radius of the, once you have switched on the electric field, once you have switched on the electric field, what will happen to the charge? So this is the magnetic field. Okay, this is, suppose this is the origin. This is our origin O. This is the y-axis. The particle enters from here. The particles enters from here. Here it is the y. Y equals to the value of y is given 2 mv by qb. 2 mv by qb. Okay, now when you switch off the electric field, the downward force, it is gone, right? Downward force, the electric force acting on the charge is gone. Okay, so electric force is no longer acting, but the magnetic force which was in the upward direction, still acting on the moving charge. Okay, and they are in the perpendicular direction. Okay, so what will happen? This charge will move like this in a circular path, right? We know that it will move in a circular path. And the time period of the circular motion we have to calculate, but before that we have to find the radius of the path. What is the radius of this motion? Okay, radius of this motion, we know that radius is mv by qb. If you remember, we have done this derivation, mv square by r equals to qvb. From there you can calculate the radius. Radius is mv by qb. So this is mv by qb. So what is the total distance? Okay, no, not total distance, sorry, I am going fast forward. What is the time given? Time given is pi m by qb. Pi m by qb. And the time period of the motion, if you remember the derivation, time period of the motion is 2 pi m by qb. Okay, you can go and check it out. I am not doing the derivation. If you forget it, you have to do the derivation anyway. But this is a very standard formula: frequency, time period, angular velocity. Those three expressions you have to remember. Okay, so time period of the motion is 2 pi m by qb. So this time is basically t by 2. So after time t by 2, okay, what is the meaning of t? Time period t. So if there is a magnetic field and if there is a particle, okay, that particle is moving in a circular path, then the time to complete one complete motion, circular motion, okay, is 2 pi m by qb. Okay, 2 pi m by qb. And if this is the time required to complete one complete motion, then this time, that is t by 2, it will complete only, it is starting from here, it will only complete half of the motion. It will only complete half of the motion. Okay, it will only complete half the motion. That means the particle will reach here. The particle will reach here. So this is the diameter basically. So if you allow more time, it will complete full cycle, but now it will only complete the half cycle. So it is basically at a distance r plus r, that is a distance of 2r. So total distance from this starting point, this is starting point, from here to here is 2r. Total distance is 2r, that is equals to 2 mv by qb. Okay, this is the distance from the starting point. Now what is the distance from origin then? Distance from origin is this much, right? Distance from the origin of the charge, this is the charge q. Okay, distance from the origin is y plus 2r, y plus 2r. Now y is also 2 mv by qb. Okay, so 2 mv by qb plus 2 mv by qb, that is 4 mv by qb is the total distance. This is the total distance. Now what is the expression for angular momentum? You have to find the expression for angular momentum. Angular momentum is given by, with respect to any point, is basically mvr. Okay, they are perpendicular, so m r cross v, generally m r cross v. Okay, magnitude, but here they are, r and v are in the perpendicular direction, r is in this direction, v is in this direction. Okay, so sine 90 degree will come, so it will be just mvr. Okay, normal expression, mvr, scalar expression, mvr. Okay, so here r is this distance, total distance from origin. We are finding the angular momentum with respect to origin. Okay, so what is m? Is not given. V is q by E by B. Okay, let me keep it here for now. And what is the distance? 4 mv by qb. Okay, or it will be 4 m square v square by qb, or 4 m square by qb into v square. Now v is equals to E by B. We have already done that. This is the condition for velocity selector. So it will be E square by B square. Okay, this v square is basically, we are putting the value. So it will become 4 m square E square by qb cube. So this is the angular momentum. So if you solve it, the answer will be option A. Now in the board exam, okay, in KCET 2023, the same question was asked and correct answer was given 0. Okay, now 0 would have been correct if they have if that particle, instead of going up, if it would have come like this, then it would have been at the origin. Okay, it would be at the origin and the angular momentum would be 0. But the force acting on this charge is not downward direction, but it is in the upward direction. So particle will go upward and not it will come back to the towards the center. Okay, the value they have thought, okay, this is the value we have given, the particle should come downwards. Particle will not come downwards. Okay, the force acting on it in the upward direction, so it will continue the motion in the upward direction, not in the downward direction. So that is why there was a confusion in this question. I am not sure finally if that question was given a bonus or not. A lot of people raised objection, but this is the correct way to solve this question. Now question number 6. A metallic rod of mass per unit length 0.5 kilogram per meter is lying horizontally on a smooth inclined plane which makes an angle of 30 degrees with the horizontal. Okay, so we have a inclined plane like this. Okay, and it is lying like this. So this is the wire, it is going horizontally, so the wire is like this. A magnetic field of strength 0.25 Tesla is acting on it in the vertical direction. Okay, so magnetic field is acting in the vertical direction. when a current I is flowing through it, the rod is not allowed to slide down. So the rod is not allowed to slide down. Okay, that means some force is acting on it in this direction. Okay, now obviously there will be some component of the force. So this is mg, another one is mg, this one will be mg cos theta, this one will be mg sin theta, and there will be some normal force n. Okay, now normal force, obviously there will be some force due to this magnetic field B as well. Now let's see, this angle is given 30 degrees. Okay, if this angle is 30 degrees, we can say that this angle will be also 30 degree, right? Parallel line, this is the bisector. Yes, this angle will be 30 degrees. So this will be sine component. So this will be a magnetic force sine theta. Okay, so and there will be a cos component over here as well. So normal component will have mg cos theta plus fb cos theta. Anyway, when a current I is flowing through it, what is the force acting on it? Force acting on it is BIL. The force acting on it BIL, and the component of the force in this direction is BIL sin theta. Okay, so it is BIL sin theta which acts on the wire in this direction, and that should balance the mg sin theta component. Now sin theta is cancelled over here. Now B is given 0.25 Tesla. Current is, we are trying to find the current. Length of the wire is not given. Length of the wire is not given. Similarly, the mass of the wire is also not given, but mass per unit length is given. So mass per unit length is given means total mass will be mass per unit length into the length of the wire. Okay, so basically L will cancel. Okay, and G, let's take G for 10 for now. Okay, I think they have solved it assuming G is 9.8, but we will try to solve it with G as other than that it will be very, very easy. Now let me explain why it is not sin theta. First, this is the direction of B, this is the direction of current, suppose. So what is the direction of force? The direction of force, current will be in this direction. So I cross B will be, the direction of force will be in this direction. Okay, current is in this direction. Okay, into the page of the paper, obviously that is only possible direction. Okay, to balance it, so current is in this direction, L cross B, right? Force is basically L cross B. So the magnetic force is I L cross B. That is the direction. Okay, so L is in this direction, B is upward direction, so it is not the component of B but the direction of force. So force will be in this direction, the magnetic force will be in this direction. So the component that we are considering, this will be FB cos theta. Okay, so the same problem, same method, but FB will be FB cos theta. Little tricky question, I know, but still. So this will be the direction of force. To balance it, so mg sin theta equals to same thing BIL cos theta. Okay, BIL cos theta. This is the now 30 degrees, obviously similar angles. Okay, so parallel, this is the bisector, so this will be 30 degrees theta. So this will be FB cos theta. Now just put the values again, same process, 0.5 into L into G is 10, sin 30 value is half, equals to B is 0.25, I we do not know, L is again L, and cos 30 is root 3 by 2. Okay, so L cancels. Okay, this by 2 cancels. So what is the value? In fact, we can cancel 0.25 with 5 with 2. Okay, 0.25 and 0.5 are this is big brother, twice the 0.25, so it will be 2. So 2 into 10 is 20. So I equals to 20 divided by root 3. 20 divided by root 3, right? Or you can approximately calculate I is equal to 20 root 3 by 3, right? We can do that. Now if we assume this 20 number to be 21, close to 21, then we can even cancel it. 3 7s are 21. Okay, now 7 into root 3 is 1.7, right? So it will be 749, 4.9 plus 11.9. Okay, 11.9 is the correct answer, and from the given answer it will be 11.32. Why 11.32? First of all, we have increased 20 into 21, so our answer should be less than whatever we have calculated, right? So this is how you can do the approximate calculation. Approximation is very important tool in case of preparation of KCET. Now not only KCET, it is required for NEET, JEE mains advance as well, right? A galvanometer of resistance 50 ohm is connected to a battery of 3 volt. Another galvanometer related question. Resistance is 50 ohm. Okay, so G is 50 ohm. Let's see whether it is required or not. So connected to a battery of 3 volts. So voltage is 3 volt along with the resistance of 2950 ohm in series. So the external resistance, now it is a galvanometer, so it will have a high resistance. So 2950 as the external resistance. A full deflection of 30 division is obtained in the galvanometer. So maximum voltage it can measure is 3 volt. Okay, so deflection is 30 divisions. In order to reduce this deflection to 20 divisions, the resistance of the series should be. So we want to reduce this for the same voltage, we want to reduce the deflection into 20. Okay, and for that the resistance in the series should be, so they do not ask you increase or decrease, they just ask you what should be the new resistance. Okay, first we have to find the maximum current that can the galvanometer can withstand. What is the maximum current? So current maximum is the limit. Okay, then maximum current you cannot ignore it. So maximum current the galvanometer can withstand is 3 divided by 2950 plus 50, right? So it will be 3 by 3000, that is 1 milliampere. So this is the maximum current the galvanometer can withstand, and if 1 milliampere current is flowing in the galvanometer, it will show 30 deflections. Okay, so if 1 millimeter current is flowing, it will show 30 deflection. So for 20 deflection, how much maximum current that can flow through it? So in that case, the current will be 1 into 20 divided by 30, that is 2 by 3 milliampere. So current in the circuit is 2 by 3 milliampere if I want to achieve the 20 division for the same voltage. Okay, so again we will use the same resistance, same formula. Only thing here, instead of 2950, I will use unknown resistance R, and that should be equals to 2 by 3 into 10 to the power of minus 3. Obviously milliampere. 10 to the power minus 3 will be coming. So this is the current, this is the new current, because I have added the higher resistance. Okay, the current is now reduced, so this is the new reduced current, and because of that the deflection decreases. Now we have to do the cross multiplication. So 9 by 2 into 10 to the power of 3, because we have done the cross multiplication, this goes up, this goes down, right, this goes down, and this 10 to the power minus 3 coming to that side becomes positive. Now this entire thing goes to the other side, so it becomes R plus 50. Okay, we are trying to find this value of R. So obviously 4.5 or R plus 50 equals to 4500, or R equals to 4450 ohm. So the resistance that we need to add is 4450 ohm. So correct answer is option C. Now next question, a circular coil of wire of radius r has n number of turns and carries a current I. The magnetic induction B at a point on the axis of the coil at a distance √3r from its center is, and the distance is √3r, that is equals to x, and we are trying to find what is the magnetic field at this point. So if you remember, what is the formula for magnetic field on the axis of a circular current carrying coil? So the only thing that they have done a n number of turns. Okay, so there will be an n multiplier. Okay, so the formula was mu naught I r square, r is the radius, Here in this case they have given r is small r, so let me use small r only. Small r square divided by 2 into x square plus r square to the power 3 by 2. This was the formula, if you remember it, right? Now we have to put, this is the magnetic field on the axis of a circular current carrying loop. Now in this case there are n number of turns, so we will add 1 n over here. This derivation we have done for our board preparation, right? So mu naught ni, okay, r square divided by 2 into, what is the x here? X is √3r. So what is x square here? X square will be 3r square, right, plus r square to the power 3 by 2. Okay, now just simplify it. Mu naught ni r square by 2 into 4r square to the power 3 by 2. So what is the meaning of by 2 here in the power? By 2 means square root. So first we will do the square root of this value. So square root of 4r square is basically 2r. So what is left? We have done the square root, so only we are left with this cube. So we will get mu naught ni r square divided by 2 into 2r cube. 2 cube is 8 and r cube is obviously r cube. So obviously we get this cancels and we get one extra r over here. So what is the value? We get mu naught ni divided by 16r. Mu naught ni by 16r, option A is correct in this case. Okay, now next question. So be careful, there is a 2 over here in this formula. Okay, that is the only thing you have to remember. Okay, when we are calculating mu naught by 4 pi, so there was one more 2 pi in the upper part, 2 pi r. So 2 pi and 4 pi cancels and we get 2 over here. This 2 is very, very important. Okay, this is a very, very important formula. Now a proton moves with a velocity of 5 into 10 to the power of 6 j meter per second through the uniform electric field E equals to 4 into 10 to the power of 6 2 I cap plus 0.2 j cap plus 0.1 k cap volt per meter, and uniform magnetic field 0.2 into I cap plus 0.2 j cap plus k cap. Tesla, the approximate net force acting on the proton. So first we have to calculate the individual forces. So what is the formula for force? Lorentz force. We remember that Lorentz force is basically Q into E plus Q V cross B. Okay, so Q obviously E is direct, so you don't need to do anything about Q into E. Q is constant, it will come over here. Okay, Q will come constant. Only thing that we have to do is the other vector parts. Now obviously what we can do is we can see that, so approximately we have to calculate what is the value of this V cross B. How to do V cross B? So V is given here j cap. V is j cap. So we will do it. We will do V cross B, right? So j cross I, j cross j, j cross k. That is the easiest solution. Okay. So the constant will be constant. 5 into 10 to the, so V cross B. I will show you how to do this. Okay, because 3 components are not there in the velocity, do not go for matrix method or determinant method. Okay, this will be easier if you do it directly. So 5 into 10 to the power of 6 is a scalar quantity, so we don't need to worry about it. Similarly, here we have a 0.2, that is also a scalar quantity. You don't need to worry about it as well. You can keep it here. Now what you have to do, you have to do the cross product of the vectors. So j cross, what is the vector over here? I cap plus 0.2 j cap plus k cap. Okay, this is the cross product we are going to do. Now I cross j cross I, so we remember I cap, j cap and k cap. Okay, so this is the direction. Okay, now if you are going in the opposite direction, j cross I means negative of k, j cross I means negative of k. So obviously 0.2 into 5 is 1, so 10 to the power of 6 only left, minus k cap. Okay, j cross I is minus k cap, plus j cross j is 0, j cross j is 0, you can ignore that. Now j cross k is plus I cap, so it will be plus I cap. Okay, so this is the resultant magnetic force. Okay, Q is common, Q is there. Okay, proton is there, proton means 1.6 into 10 to the power minus 19, so we will keep that in mind, not now. Anyway, now we have to do this, right? E plus V cross B. So basically we have to add them. Now what is the value of E? E is 4 into 10 to the power of 6. Here we do not have that 4. So what we will do, we will take the 10 to the power of 6 as common. So E plus V cross B means we will take the 10 to the power of 6 common, and in bracket we will write 4 into this entire thing, 2I cap plus 0.2 j cap. This is slightly lengthy question but not super difficult. 0.1 k cap. Okay, plus V cross B, this is common here, so we can simply add minus k cap, okay, plus I cap. Okay, so you will get sorry, one mistake I made here. This 4 will be multiplied inside. This 4 will be multiplied inside. So it will be 8 I cap plus 0.8 j cap and 0.4 k cap. This 4 will be multiplied with all the terms, right? So this is what we have missed. Now 10 to the power of 6 into 8I plus I is 9I plus, there is no other j over here, 0.8 j cap plus minus plus 0.4 minus 1, that is 0.6 k cap with a negative sign. Now this much is okay. This much is okay. Now what to do after that? We have calculated the main part of the problem. Now what you have to do, you have to find the magnitude of the force. So this is the, so you have to find the magnitude of this entire thing. So magnitude of this entire thing is basically 10 to the power of 6 into square root of 9 square plus 0.8 square plus 0.6 square. Okay, this is the formula. Ax, Ay, Az. So the magnitude is Ax square plus Ay square plus Az square. Now here what we will do, we will do an approximation. We will say that okay, these two terms are very, very small compared to this number. So we will ignore it for now. We are trying to find the approximate value, so we will ignore this number completely. So what is the value of 9 square? Value of 9 square, square root of 9 square is 9. So this is 9 into 10 to the power of 6. This is the part that you have to be familiar with so that you don't make any mistake. So 9 into 10 to the power of 6. Now we will put it here, 1.6 into 10 to the power of minus 19 and 9 into 10 to the power of 6. So it will be 9 ones are 9, 6 nines are 54. So it will be 14.4 into 10 to the power of minus 13. Okay, 14.4 into 10 to the power of minus 13. So if you see all the options, which one is correct? Obviously option C. Okay, if you have included these two values, it would increase slightly more from here and you would get this to be 15. Okay, so this is the approximate method. So this is little tricky, little long question, but in KCET from time to time this type of questions has come, so you cannot ignore might saying that okay, this kind of question is not going to come because KCET exam is easy. Not at all. Okay, KCET has, as I said, 10 to 15 questions easy, 10 to 15 questions difficult. Okay, so you have to be prepared for those type of questions as well. Okay, so basically you cannot attempt this question at the beginning of your paper. You see this question, you skip it. Later on when you come back, you have to have at least 25-30 minutes in your hand and solve these difficult questions one by one. A solenoid of length 50 cm having 100 turns carries a current 2.5 ampere. The magnetic field at one end of the solenoid is. So we have a solenoid. Okay, so solenoid, if it is a constant solenoid, okay, if it is a constant solenoid, then at the on the axis of the solenoid the magnetic field is constant, that is given by mu naught n into I. What is n? N is number of turns per unit length. Okay, now they asked you to not to find at the center but on the one end. They asked you to find the magnetic field at one end. How to do that? We can consider that, suppose this is the length 50 centimeter. We can consider another solenoid which is also of the same length 50 centimeter on this side. Okay, now having the same number of turns, even though it is not change anything anyway. So basically this is how you can say, okay, what is the magnetic field over here. So if you consider these two, this is a complete single solenoid, the magnetic field you can calculate. Now you say that okay, this part is missing, so it will be basically whatever we have calculated divided by 2, right? So this part is not there. We have imagined this part to calculate the constant magnetic field mu naught Ni. So on the end it's basically mu naught Ni by 2. Okay, what is n over here? N is number of turns per unit length. So total number of turns is 100 and length is 50 centimeter. We have to convert it into SI unit, so that is 50 meters. Okay, so this is the unit, or it will be 200 per meter. Okay, this is the number of turns. Now you have to put it into the formula. So magnetic field on the end is basically mu naught. Mu naught is 4 pi into 10 to the power of minus 7. N is 200. Current I is 2.5 ampere divided by 2. This is very, very important. 100. Okay, so 2.5 into 4 is 10. So 10 into 100 pi into 10 to the power of minus 7. So what is pi? 3.14 into 10 to the power of minus 4. So it will be 3.14 into 10 to the power of minus 4 Tesla. Okay, so this is the answer. Okay, be careful because they have asked you one end. If it was the center, then this two division was not required. Okay, because it is on the one of the end, you have to divide it by 2. Okay, now a strong magnetic field is applied on one stationary electron, then the electron moves in the direction of the field, move in an opposite direction of the field, remains stationary, starts spinning. It remains stationary because magnetic force acts only on the moving charge, it does not act on a stationary charge. So no matter how strong magnetic field you apply, the charge will remain static. Two parallel wires free in space are 10 centimeter apart and each carries a current of 10 ampere in the same direction. The force exerted on the one wire on the other per unit length is. So two wires carrying current, okay, separated by 10 centimeter. Okay, you have to find what is the force on each of them. Okay, now what is the direction? Both are carrying current in the same direction, so it will be attractive force. Okay, repulsive options are not correct, so these two are incorrect. So either this one or that one, and we have to find the direction. Okay, in fact I can guess the answer. Okay, let's see. So what is the force per unit length between two wires? It is mu naught by 4 pi I A I B by d square. Mu naught by 2, sorry, not 4 pi, it is mu naught by 2. So it is mu naught by 2 pi Ia Ib by d. Okay, now let's put the values of everything. So mu naught is 4 pi into 10 to the power of minus 7 divided by 2 pi into Ia Ib, both are carrying a current 10 ampere. So 10 into 10, and the distance is 10 to the power of 10 centimeter, right? Yes, 10 centimeter. So 10 into 10 to the power of minus 2. So one of the 10s will cancel and 2 will cancel. You will get 2 into 10 to the power of minus 4. Okay, so 2 into 10 to the power minus 4 Newton per meter. Now, as I said, I can guess the answer. How I can guess the answer? If you remember the definition of ampere from the force acting between two parallel currents per unit length, okay, so this was the formula, this was the value for 1 ampere current flowing through both the wires kept at a distance of 1 meter. Okay, so that is very small value. Now if they are kept at a very closer distance, that is 10 centimeter, current is no longer 1 ampere, then definitely this is not possible. So only logical answer would be this. Okay, so without even solving this question, I can mark this as the correct option, because obviously to guess the answer you have to have a lot of confidence in you. Definitely you can check and correct that whether your assumption was correct or not, but if you practice a very long time, you can easily guess this is the correct answer, not this one. Obviously repulsives are not correct. Force must be attractive because currents are in the same direction. Now let's see this graphical question. A toroid with thick windings of n turns. Now toroid is part of the deleted syllabus, so I am not going to solve this question. Now let's move on. A tightly wound long solenoid has n turns per unit length. The radius r and carries a current I. A particle having charge q and mass m is projected from the point on the axis in a direction perpendicular to the axis. So basically we have a solenoid, okay, like this. I am just drawing only one cross section of the solenoid, otherwise it will be very complicated. So this is the cross section of the solenoid. Solenoid is into the page of the paper. Okay, so this is the axis is also along this. Now a charge q is placed like that. It is moving perpendicular to the direction, perpendicular to the axis of the solenoid. Okay, in a direction perpendicular to the axis of the axis. The maximum speed of the particle for which the particle does not strike the solenoid is. So there will be a magnetic force acting on it, and the particle will rotate in a circular path like this. Okay, the particle will rotate in a circular path like this. This is the starting point. So obviously the particle can go like this. Now without touching the solenoid means the radius should be the radius of the solenoid is small r. So that means the radius of the circular path must be r by 2. The radius of the circular path must be r by 2. Now we know that mv square by this radius, circular path radius, mv square by this radius should be equals to qvb. Right, this is the condition. From here we are just putting the value of r by 2. Now we are just trying to calculate the velocity v. So velocity v will be v equals to qb r by 2 divided by m. Now what is the magnetic field here? Magnetic field due to a solenoid, we just solved mu naught Ni. Okay, number of turns is small n, number of turns per unit length is small n. Mu naught, obviously mu naught, so you have to just put the value over here. So q into mu naught Ni r by 2m. Okay, so this is the value. Let's see which one is mu naught Ni qr by 2m. So option B is correct. Okay, so this is the logic you have to remember. So sometimes even though the question is easy, you don't understand the logic of the question and you answer it incorrectly. Okay, now next question. Which of the field pattern given below is valid for electric field as well as magnetic field? Okay, so now electric field, we know that electric field is starting at positive and ending at negative, whereas magnetic field lines are basically closed lines. Okay, they go for positive to negative, and inside the material they go through the wire, right? So for example, if this is a north-south dipole, magnetic dipole, okay, what happens is that it starts from north, it goes to south, and inside it goes to south to north, right? But this is not possible for electric field line. So electric field line cannot have this. This is possible for electric field, this is possible for magnetic field. Okay, this center part is not super clear. Only circular pattern is possible in some cases for electric and magnetic field both. So this is the only correct answer for this question. Now, next question. The magnetic field at a origin due to a current element dl placed at a point with a vector position r vector is. Okay, so basically they are asking you about the Biot-Savart law in a vector form. So Biot-Savart law says that it is mu naught I dl cross r. So dl cross r by r cube. Okay, so this is the thing you have to remember, that Biot-Savart law says that the magnetic field is mu naught I, okay, dl cross r cap by 4 pi r square. Okay, in Biot-Savart's law, instead of this, if you write it in the scalar form, okay, then it was sine theta over here, right? So there was only one r square in the denominator. Now here if you see, all of them has one r in the numerator, right? All have one r in the numerator. That means you are adding one extra r over here. So if you are adding one extra r here, then you obviously have to divide it with this extra r. So it will be r cube. So correct answer is mu naught I by 4 pi dl cross r cube. You have to remember it is dl cross r, not r cross dl. That is the only thing that you have to remember, and this trick. Okay, this is the old trick. Now in the given figure, the magnetic field at O. So here we have, this is also a very common question. We have solved this question in our PU class as well. So this is the current direction. Okay, it is coming like this. So first we have to find the magnetic field due to this current carrying circular loop at the center. So what is the expression for magnetic field of the circular loop at the center? Magnetic field due to a circular loop at the center is basically mu naught by 2, okay, I by R, right? Mu naught by 2 I by R. And what is the expression for current carrying wire? For an infinitely current carrying wire, it is basically mu naught by 2 pi I by R. Almost same. Okay, in one case there is a pi here, in another case there is no pi here. Okay, now let's see. First of all, we have to identify what is the magnetic field due to this circular loop. If the circular loop was complete, this is the magnetic field. Okay, this is the magnetic field if circular loop is complete. Now this is not complete. How much it is missing? It is missing by angle 90 degrees. It is missing by an angle 90 degrees. So what is the magnetic field due to this part? Magnetic field due to this part is, say, B1. Total magnetic field is what? Total magnetic field is mu naught by 2 I by R, and that is for angle 360 degrees. But we have only 270 degrees present here. Okay, so this is one way to solve it. Okay, you can multiply with 3 by 4 as well. Actually, you will get 3 by 4 over here, 3 by 4 over here, or you can use the angle as well. So 3 mu naught I by 8R is the magnetic field. What is the direction? Current is going like this, so it will be into the page of the paper. Okay, always curl your fingers and try to find the direction of magnetic field. So if you curl your finger like this, the magnetic field is into the page of the paper. Now this wire is this formula is for an infinite wire, but here it is not infinite, it is bending. So what you can say that, okay, let me imagine that this wire was continuous, but somehow it was cut in half at this point. So basically the same logic that we did for solenoid at one of the end, right? So here also you will do the same. So here is basically half of the entire magnetic field. Now what is the direction? For straight wire, we point our fingers, first we point our thumb in the direction of current, and then curl our fingers. This curl direction represents the direction of magnetic field. So magnetic field due to the wire, this circular part is into the paper. Magnetic field due to this is also into the paper. So both of them are into the paper, so they will basically added, they will get added, right? Now what is the magnetic field due to the wire? Say B2 is equals to half of the entire magnetic field, mu naught by 2 pi I by R. Okay, the distance is same, R for this wire as well. So now you have to add them. What you will get? The total magnetic field is B1 plus B2 equals to 3 mu naught I by 8R. So the question, as you can see that question from this chapter is slightly lengthier than the other chapters usually. Either it is very easy, you can answer them in one line, or it requires some mathematical calculation to solve it. Okay, so it will be 3 by 8 mu naught I by R plus mu naught I by 4 pi R. So correct answer is option A in this case. Okay, so this question, this is a common question anyway. I guess this is just to practice. This exact question will not come. Okay, a long cylindrical wire of radius R carries a uniform current I flowing through it. Okay, long cylindrical wire of radius R carries a uniform current. Okay, the variation of magnetic field with the distance R from the axis of the wire is shown. Okay, so magnetic field is basically what is the here we have to apply the I assuming that this is a conducting wire. Obviously wire carrying current means it's a conducting wire, so all the charges or all the current that basically stays on the surface of the wire. Inside the wire we can consider that the current is 0. Okay, so current is 0. Now if you apply the B dot ampere circuital law, B dot dl equal to mu naught I. Okay, so basically you see that inside the wire magnetic field will be 0. Inside the wire is magnetic field is 0, and outside the wire it varies. The same formula we have done last problem, mu naught by 2 pi I by r. So it inversely proportional to distance, so it decreases like this, and inside it is basically 0. So this is the correct answer. Option D is correct answer. Now, next question. A cyclotron used to accelerate proton. Now cyclotron is not there, but this question is solvable. Okay, a cyclotron is used to accelerate protons, deuterons and alpha particles while exiting under similar conditions. The minimum kinetic energy is gained by. So minimum kinetic energy is gained by means who has the smallest velocity. Okay, so velocity is what was the formula? mv square by r equals to qvb. So cancels, so v is basically qb by mr. Okay, so it is said that cyclotron used to accelerate, both are getting accelerated, same radius, everything is same, magnetic field is same, only q and mass will be different. So let us find the magnetic field for proton, that is 1h1. So 1h1 means charge is 1 electron and mass is 1 only into r. Okay, what is mass of the deuteron? Deuteron has only 1 electron, but it has mass of double. Okay, r. Now what about helium or alpha particle? Alpha particle has double charge, it has 4 times mass. Okay, 4 times mass. So it will be 1 by 2. So as you can see that now what is the kinetic energy? This is not done yet. Okay, as you can see that velocity of deuteron and helium are same. Deuteron and helium are same, but what about the kinetic energy? Kinetic energy is basically half mv square. Kinetic energy is half mv square. What is the kinetic energy of proton? Kinetic energy of proton is half m p into this whole square, so e square b square divided by mp square into r square. Okay, now one of the mp will cancel, so you will get this is the value. Now let's try to find the kinetic energy of the deuteron. This is interesting. Okay, you cannot solve it in one answer. So deuteron will be 2md into e square b square by 2mp whole mpr whole square. Now 2mpr whole square means 4mp, right? 4mp square. So here you will get 4mp square r square. So 2 will be cancelled over here, 2mp mp. Okay, rest of the part is same, that's why I am not cancelling or not multiplying anything. So here we have that this is basically this kinetic energy is half of kinetic energy of proton. Okay, so basically this is less so far. Now let's find the kinetic energy for the helium. So helium will be half m 4 mp. Helium has 4 mass. This part will remain same for helium, E square B square by 4 mp square r square. So 4 cancel. So again kinetic energy of helium and hydrogen are same. Kinetic energy of hydrogen and helium are same, but velocity of deuterium and helium are same. But as you can see that kinetic energy of deuterium is less. It is half of both of them. Okay, so it is basically deuteron is the correct answer. Okay, I used to say deuterium, but deuteron is also correct. So deuteron is the correct answer for this question. So this is a very, very interesting question, and you cannot guess the answer without solving it. Okay, unless you are familiar with this answer. Okay, now let's solve. Two long straight parallel wires are at a distance 2d apart. They carry steady equal currents flowing out of the plane of the paper. Okay, so here we have two long straight wires. So these circles are basically representing the current carrying wires. So both of them are carrying current outside of the paper. Okay, the variation of magnetic field B along the line XX is given by. Now, as you know that the magnetic field is attractive in nature. Okay, so let's see. Let us try to find out the direction of the magnetic field. So the magnetic field is circular. Okay, magnetic field is circular. What is the direction? Direction is in this direction. So due to this, the magnetic field of this wire will be circular. Okay, and it will be in this direction. Okay, and magnetic field this will be also in this direction. It will be. So they will cancel each other. So as you can see that magnetic field at the center, they will be cancelling each other. So they will be, it will be 0. Okay, and so basically that means that if you consider this is positive, it is increasing, then it will be in the opposite direction. So it will be decreasing. Magnetic field will definitely be maximum like this, and it is in the opposite direction again. Close to the wire is maximum, close to the wire is maximum, but if you are considering this is positive, this direction is positive, then this direction is positive over here. So definitely this is the correct answer. So option D is correct in this case. Okay, these are not possible. Okay, opposite, because of the opposite direction, they cannot be same direction, because of they are in the opposite direction. Here magnetic field is in this direction, here the magnetic field is going from up to down, right? So obviously they will be opposite direction, right? So here this is the correct answer for this question. Now next question, again toroid based question. Next question, in a cyclotron a charged particle, okay, this is also cyclotron based question. A number of turns in a coil of galvanometer is tripled, then both voltage and current sensitivity remains constant. Voltage sensitivity increases 3 times and current sensitivity remains constant. Both voltage and current sensitivity decreases by 3%. Voltage sensitivity remains constant and current sensitivity increases 3 times. Okay, so now let us understand what is the voltage sensitivity, what is the current sensitivity. So current sensitivity is galvanometer constant divided by current, right? This is the current sensitivity. Now if you increase and the galvanometer constant is basically has some term, I don't exactly remember, n phi k, right? N phi k. So this is the galvanometer constant. So definitely it is proportional to the number of turns, galvanometer constant. So if you increase the number of turns n times, then definitely the current sensitivity will increase 3 times, right? If you increase the number of turns 3 times, current sensitivity increases 3 times. Now what about voltage sensitivity? Voltage sensitivity is G by V. Okay, so that is n phi k by I into R. right? Now this resistance R is directly proportional to the length of the coil. So if you increase this N by 3 times, if you increase this N by 3 times, okay, the resistance will also increase by 3 times. Okay, so because the more length, right, resistance is, we have learned rho L by A. So if you are increasing the number of turns, that means you are increasing the length of the wire, right? So length of the wire is increasing 3 times. So basically resistance will increase, and we can say that voltage sensitivity remains same. So voltage sensitivity remains same, but current sensitivity increases 3 times. Okay, so voltage sensitivity remains same and current sensitivity increases 3 times. Option D is correct. Very interesting question, logic question. A circular current loop of magnetic moment M in an arbitrary orientation in the external uniform magnetic field. The work done to rotate the loop by 30 degree about an axis perpendicular to its plane is. So what is the initial case? What is the initial potential energy? Potential energy is basically, we know that mb cos theta. Okay, so initially whatever magnetic, so initially suppose whatever is the arbitrary orientation, let us assume that that is basically mb. Okay, cos theta, we can assume that for that theta is obviously so we have to consider the initial condition, the this u is basically 0, or basically what you can do, delta u is equal to mb cos theta. That is also okay. Delta mb is okay, 0, so you don't need to consider this part. So what is mb? M is given, b is given, theta is given 30 degrees. So arbitrarily cos 30 degrees, so it will be mb into root 3 by 2. So the work done is root 3 by 2 mb. Okay, so answer is root 3 mb by 2. Now this is about potential energy, this is not about torque, so sin theta will not come. Work done means potential energy, and for potential energy formula is mb cos theta, not mb sin theta. So be careful. Now this is another question. The magnetic field of the at the center O in the given configuration is. So here it is similar to that one problem we solved. In that case it was the angle was 90 degrees, here the angle is 60 degrees. So the formula is same, that is mu naught by 2 I by R, right? This was the formula, and due to the magnetic field on the center of a coil, right? Now here we have 60 degrees. Okay, total angle, this formula is valid for 360 degrees, right? This formula is valid for 360 degrees, but in this case we have reduced it by 60 degree. So what is this angle? This angle is 360 minus 60, easy, 300. So just need to multiply it, 0 0 cancels, 5 6 30, 6 6 36. So it will be 5 mu naught I by 2 into 6, 12 R. So this is the magnetic field at the center, 5 mu naught I by 12 R. Next question, the correct Biot-Savart's law, again similar question. dB equals to mu naught by 4 pi I dl cross R by R cube. Be careful, this will be the correct formula. Okay, this is not correct if because there is a vector on the left hand side, right hand side this is not a dl vector, so be careful, these two are not correct. Okay, next question, an electron is moving in a circle of radius r in an uniform magnetic field B. Suddenly the field is reduced to B by 2. The radius of the circular path now becomes, okay, so we know that mv square by r equals to qvb, okay, or r equals to mv by qb. Okay, now velocity is remaining constant. If you decrease the magnetic field by b by 2, if you decrease the magnetic field by b by 2, that means the new radius will be mv by qb by 2. So this is in the division, it will go up and you will get this is nothing but 2r. So radius will be doubled. If you reduce the magnetic field by half, the radius will be doubled. A charge q is accelerated through a potential difference v. It is then passed normally through a uniform magnetic field where it moves in a circle of radius r. The potential difference required to move it in a circle of radius 2r. So first we have to remember that what is the formula, what is the radius. It is mv by qb. Now here this is the velocity, not the potential difference. So if you accelerate a charge in a potential v, okay, then it gains an energy. Once it is coming out of the potential, it gains an energy q into v. Okay, now in this case what type of energy it is gaining? It can gain only one type of energy, that is kinetic energy. So what is the formula for kinetic energy? Half mv square equals to q into v. This v is the voltage. So from there we can say that okay, velocity is proportional to square root of the voltage. We don't need to do the exact mathematics over here, you just need to find what is the relationship with this. So from there basically we can say that so radius is directly proportional to velocity. So velocity is proportional to square root of voltage. So radius will be directly proportional to square root of voltage. Okay, so r1 by r2 equals to square root of v1 by v2. Now r2 is twice r, right? R2 is twice r. So r by 2r equals to v by v2. So just cancel, you will get v2 equals to 4v. Okay, square, you have to do the square. So it will be 4 times v is the correct answer for this question. Now next, a straight wire of length 50 centimeter carrying a current 2.5 ampere is suspended in mid-air by uniform magnetic field of 0.5 Tesla. The mass of the wire is. So this is a similar question of the part, a little difficult question we have solved in case of that inclined plane problem. Okay, length is 50 centimeter. Okay, current is 2.5 ampere. So suppose this is the weight mg, okay, and this is the force, magnetic force. Okay, so what is the magnetic force? Magnetic force is BIL sin theta. Now here the theta is 0. Okay, so we just need to put the values, and that should be equals to mg. Only if these two forces are balancing each other, then only the wire will not fall, it will float. Okay, so what is B? 0.5 Tesla. Current is 2.5 ampere. Length is 50 centimeter. 50 centimeter means 50 into 10 to the power of minus 2. Mass we are trying to find, G is 10. Okay, so M is 0.5 into 2.5 is 1, okay, 1.25 into 50, this 0 cancels, okay, into 5 into 10 to the power of minus 2. So it will be 125, 6.25 into 10 to the power of minus 2. So it will be 625 grams. Okay, 62.5 grams. Okay, minus 2, right? So 62.5 grams. So correct answer is option C. Okay, it will be 62.5 into 10 to the power of minus 3 kilograms. So 62.5 means 62.5 grams. Okay, be careful. Next, magnetic field at the center of a current carrying loop of radius 0.1 meter is 5 into root to the power 5 times that at a point along its axis, the distance of this position from the center of the loop. So again, what is the formula for magnetic field at the center? It is mu naught by 2r, mu naught I by 2r, right? And that is basically it says that it is 5 root 5 times stronger than at a point at some other distance, and from some other distance on the axis. What is the formula for that? Mu naught I r square divided by r square plus x square to the power 3 by 2. Okay, so this is the formula. So here I cancels, mu naught cancels, these two cancels. Okay, so what we get, we just take it on this side, r square plus x square to the power 3 by 2 equals to 5 root 5 r square, and this r multiplied into r. Okay, so it will be 5 root 5 r cube, or what we can write in this side as root 5, okay, root 5 r whole cube. Interesting. 5 root 5 means root 5 cube, right? So 5 root 5 r square. Now we can take this out. So what is that? R square plus x square to the power half. If we take the cube root on both sides, okay, this cube part will be gone. We will be getting 5r. Now what? Now we have to do the square on both sides. So r square plus x square equals to 5r square. Okay, squaring both sides. So x square equals to 4r square, or x equals to 2r. Okay, so what is the radius? Radius is 0.1 meter, so it will be 2 into 0.1, that is 0.2. Okay, so 0.2 meters. So this is also a learning that whenever you are solving problems, if not required, do not put the values at the beginning. If you want to solve this question with the values from the beginning, it will not only take more space, it will also, every time you are solving it, you have to use the same values. If you are okay, this is just a formula, you are inserting the values to calculate the answer, then fine. In this case, as you can see, that you can easily compare, and you can easily this is already given to you. So you, after reaching to this stage, you realize that I don't need to put the values at this point. Okay, I can simplify it. Once I have simplified, at the end I just need to put the value. Okay, this is also a learning for you. Now if you have any doubts, any questions, you can mention in the comment below, and also if you have not yet subscribed to our channel, don't forget to subscribe to our channel, like this video. I'll be back with more new chapter, one new chapter very soon. Till then, bye.